Good morning, everybody. It's a real pleasure for me to be here. I see some familiar faces. Some of my former students at UC Davis have made it to become bovine practitioners, I see, and I'm happy that that's the case. I live and work in Davis, California, in the Animal Science Department at UC Davis. We have 1,500 undergraduate students, the largest animal science major in the country. Most of those folks want to be just like you. Everybody wants to be a vet, right? Seriously, I'm not kidding you. They all want to be vets. And so it's a real pleasure for me to speak in front of a group of veterinarians. And I can tell you what you do is so important. So important to society. It is so important for the world. And I hope that some of the information I will share with you will help you, will equip you in some of the criticism that you experience when dealing with clients, when dealing with the public. Because cattle are in the crosshair of so many societal discussions these days. And I would say that the Achilles heel of cattle these days is methane, is the carbon footprint of livestock, and particularly ruminant livestock. And so that's what I want to talk to you about. So in addition to being a professor doing teaching and research, I'm also a science communicator. And of course, I'm an extension specialist as well. And a year ago, somebody asked me, Frank, why are you not on Twitter? And I said, I'm not on Twitter because Twitter is stupid. But you know what? I was stupid because I waited for so long. And since that last year, I have been quite active on Twitter, and now I have 3 million people checking in on my account every month. 3 million people. How in the world could I get that kind of impact with anything else? Certainly not with peer-reviewed publication. Of course I do those, but I think science communication is very important. If you are not on Twitter, I beg you, please be on Twitter, because you are important influencers and we need your help. So this here is my Twitter handle, GHG for greenhouse gas, GHG Guru. I also have a blog, and I think many of you will enjoy that blog because it breaks down a lot of material that you're not really specialized in yet that you might find important. Feel free to take photos of any of my slides. If you want to, send me an email, and I'd be happy to send you a PDF of my presentation as well. So I first will talk about climate change and greenhouse gases. It's a little bit technical, but of course everybody in the room is used to technical content. But this one is really about what greenhouse gases are, what they do, and the particular role of methane. I start out with this slide here. It shows the North Pole and a yellow line that depicts where the ice cap over the North Pole was 20 years ago. And in white you see where the ice cap is or was 10 years ago. Now I don't have a satellite image that's more recent, but if I were to have one, you would not see any ice here. For the first time ever, we can now circle around the North Pole on a boat. Never before were we able to do that. We see distinct changes throughout the world, whether it's the tundra in Siberia that's thawing, that was previously frozen, releasing now large quantities of methane, whether it is the poles. There are many different regions in the world where we see distinct changes happening. And most climate scientists will tell you that human activity has something to do with that. That human activity has something to do with that, and particular gases that we produce called greenhouse gases. What you see on this slide here is the sun radiating down solar beams to the surface of the Earth. And they are reflected back. Normally they would go straight back into space. So solar radiation comes in, hits the Earth, and is then reflected back into space. And that would be the case if there weren't these so-called greenhouse gases. And these greenhouse gases, gases such as CO2, methane, nitrous oxide, and others, these greenhouse gases practically form a blanket over our troposphere, a blanket keeping the heat from solar radiation in our atmosphere. And the more of these gases we have, the thicker the blanket becomes. Does that make sense? So these gases have an attribute to them, and that's called global warming potential. They have the potential of trapping the heat from the sun. Here this slide shows 3 greenhouse gases, CO2 on the left, methane in the center, and then nitrous oxide on the right. And these 3 greenhouse gases differ in many different ways. But probably the one that you hear about most often is the so-called global warming potential, which says that one molecule of methane is 28 times more potent, 28 times more potent than one molecule of CO2. And it also says that one molecule of nitrous oxide is almost 300 times more potent than CO2. I'll give you an analogy. Imagine you were to put coffee into a beverage container in the morning. To keep it warm, you put it either into a styrofoam cup, or into a China cup, or into a Starbucks $20 insulated cup. The same coffee goes into those 3 beverage containers, but we all know it stays warm different length of time. The same is true for these gases. When these gases, and my fist depicts one, when these gases are hit by a solar beam, they trap the heat, and they do so at different potencies, with methane being 28 times more potent than CO2, and nitrous oxide 300 times more potent. This is where I call them special friends, and I'm being facetious here, because they're really not our special friends, but where our special friends end the story. But the story does not end there, because in addition to differing global warming potentials across these gases, there's one more difference that nobody talks about. And I'd be surprised if you heard about it. Before I talk about methane, just really quickly, the vast majority of climate scientists will tell you that the number one human activity around climate change is the use of fossil fuels, which includes oil, coal, gas, that is carbon that is stored in the ground, form of fossilized plant material. That plant material accumulated in the ground for a very, very long time. It fossilized over millions of years, and since then we extracted, within the last 60, 70 years, half of that fossil fuel. And what did we do with that fossil fuel? We burned it. So that's carbon that was in the ground for a very long time. We took it out of the ground, and this slide depicts it. On the bottom panel, you see the years 1750 to 2000. The blue line shows when throughout that time period we extracted fossil fuels, we burned them, and as a result, you now have all that CO2 in the atmosphere. The whole world talks about the Amazon fires, right? And the world is concerned about that, and so am I. But the world does not talk about all of these forests that are beneath the ground, underground, that had accumulated there for hundreds of millions of years, that we are extracting in form of fossil fuel and that we burn at record speed. That's the oil, coal, and gas we all burn every day, when we drive, when we heat and cool our homes, and so forth, when we fly, and I'm a culprit of that, I promise. But instead of focusing on that, and that is the 800-pound gorilla, instead of focusing on that, our special friends say, no, it's not fossil fuel, it's farting cows. A couple months ago, Congresswoman AOC from the Bronx tweeted, who has seen that tweet a couple months ago, where she said that in order to change global warming and in order to reduce that, we need to get rid of farting cows and we need to do less air traffic. Now, as a person who is in that sphere, I responded to her and I told her that the content of her tweet was incorrect, and I corrected it in a way that was not lecturing, not condescending, and so on. 2 hours after I did that, all mentioning of cows, farting or not, were taken off all her social media accounts. And a week later, her office contacted mine, and they asked for consultations around the Green New Deal. And since then, we had 3 follow-up meetings. So I think that this is really important. I think this is really, really important. And, a couple of months ago, I gave testimony before the U.S. Senate, and I can tell you, I was encouraged to see a lot of people in the legislature who are actually quite mature and quite interested and understanding in and around agricultural topics. They get it, that agriculture is a strategically important sector of society. They got that. I talked to 20 federal congressmen. The other day, Elizabeth Warren was on TV, and she was asked if we need to get rid of straws and burgers and so on, and she said in public, she says, well, I understand that people are concerned and want to do their part. She understands that. But that these personal actions are just a smokescreen for the much larger issue of fossil fuel use. I almost fell off my chair when I heard her say that. But now I get to hear this more and more often as a result of us stepping forward and educating those people. And I think it's very important. And it's not just people like me, it is also people like you who have that responsibility. Now I talk about methane. Now I come down my soapbox here. I think this is a very important slide. I apologize for the small font, but there's nothing I can do about it. It shows the global methane budget. What it shows is that there are different sources of methane on the left, and then there are sinks of methane on the right. Our special friends only talk about sources, such as fossil fuel use, agriculture, biomass burning like the Amazon burning, wetlands, other natural emissions. All of them combined, globally, amount to 560 teragrams. 560, just remember that number, 560. That's where the discussion stops when you read our news. But globally, there are not just emissions, there are also sinks. And in particular, one atmospheric process called oxidation. To be precise, hydroxyl oxidation. That process alone gobbles up 15 teragrams. Altogether, total sinks in the world are 550, and total sources are 560 teragrams. How in the world can it be that the entire world only talks about that side of the budget and leaves out this side of the budget? It doesn't fit their agenda. I think that's very true. I hope it fits your agenda, and I hope you remember that methane is not just produced, but also consumed. So what is hydroxyoxidation? When you have a methane molecule in the atmosphere, sooner or later, it gets in contact with a hydroxy radical, with a radical. That radical steals a hydrogen of that methane and converts it into CO2. And that happens within 10 years. And here comes one of the take-home messages you must remember. Forget everything else I say, but do remember that. CO2 and methane are distinctively different, not just because of their differences in global warming potential, but also, and even more so, because they have different lifespan. CO2 is in the atmosphere for 1,000 years. A CO2 molecule, once it comes out of your exhaust pipe, not yours, but your car's exhaust pipe. Sorry, didn't mean to be flippant, but it just came out. A molecule of CO2, once it's in the atmosphere, stays there for 1,000 years. A molecule of methane stays in the atmosphere for 1 decade. There's nothing that destroys methane, but there is something that destroys, there is nothing that destroys CO2, but there is something that destroys methane. 10 years. So not just is methane produced, methane is also consumed. 560 on the one, 550 on the other, globally, teragrams. This slide is very important. I take you back to your high school days. Think about plants. What does a plant need to grow? It needs CO2. That's the carbon it needs to produce carbohydrates. What else does a plant need to grow? Sunlight and water. These are the 3 things any plant needs. So let's just think about the plants, whether that's grasses or corn or so. These plants gobble up CO2 from the atmosphere, and that's the carbon they need to produce the carbohydrates. You see the carbohydrates here. They also need the sunlight. The cow now eats that forage, or the corn, and converts some of the carbohydrates into methane. What are the carbohydrates that we're dealing with here? Largely cellulose, right? When large ruminants are on rangeland or so, they eat grass, and that grass contains cellulose. Cellulose is non-digestible to humans and other monogastric animals, but only to ruminant animals such as cattle and sheep and goats. I don't need to tell you that. But the public is unaware of that. What these animals eat, by and large, over 80% of what large ruminants eat is non-human edible. And they don't just recycle feedstuff. That's what many people say. They upcycle them. They take non-human edible feed and make it into the highest value animal source food that there is on the planet. They take something that's non-human edible and they make it into something that is of highest nutritional quality. That's what cattle do, and the other ruminants as well. So CO2, sunlight, make grasses grow, the animals eat them, some of that is then produced, expelled as methane gas, and that methane gas stays in the atmosphere for 10 years, after which that methane is converted into CO2. That CO2 amount here is lesser than the total amount of CO2 that goes back into plants. If you do not add additional livestock to a herd, let's say the US herd, and we haven't done so in decades, if you do not add additional livestock to the national herd, you're not adding additional new carbon to the atmosphere. If you don't add more livestock to our herd, we are not adding additional methane to the atmosphere. If we don't add additional methane to the atmosphere, we are not adding additional warming. Did you hear what I just said? What I'm telling you is that as long as we don't grow our livestock herds, we are not adding additional methane to the atmosphere. We are not adding additional warming. But every time you drive a car, you are adding new additional greenhouse gases to the atmosphere. Why? Because if you look at this graph again, on the so-called biogenic carbon cycle, that's the one on the left, where CO2 from the air goes into the animal, into the air, into the plant, into the animal, into the air, into the plant, the animal, the air. That's a cycle. While that's happening for the biogenic carbon cycle, it's not happening for fossil fuels. On the right side, you see fossil fuels that were in the ground for a long, long time. And as I just showed you, we are extracted a lot of that fossil fuel. And what do we do with it? We burn it and therefore take that carbon that was in the ground for so long and we put it in the atmosphere. And that's a one-way street. You take it from down there, you put it in the atmosphere, it accumulates. That is why CO2 levels are always going up and up only. Don't ever allow someone to compare cows to cars. It is a totally flawed talking point. And it is misleading to a point where it's dangerous. Because our special friends do one thing. I understand their agendas. I've studied them long enough. But what they really do is they're trying to convey the public to believe that all that matters is to change what we eat. And as long as we do that, we can relax upon everything else we do. And that's dangerous. That is dangerous, and it does the opposite to what needs to be done in order to reduce our climate impacts, which is we do need to tackle the fossil fuel issue. And we need to do this aggressively, and we can. So everybody now understands there's a biogenic carbon cycle for livestock, which goes from the atmosphere to plants to animals, the atmosphere to plants to animals. And in that cycle, we are not adding new carbon and not new warming to the atmosphere. But on the fossil fuel side, we do, because we are taking large volumes that were stored down there, we are burning them, we are putting new carbon to the atmosphere. And that adds to warming. Now, if you want to learn more about this, take a photo of this slide here, and it shows two articles from a colleague at Oxford University, where I was last week. These people have no connection to animal agriculture whatsoever, but they're experts around methane. And they have put out a couple of papers that you should be aware of. These are two of them. And they describe what I just said in some detail. If you need more technical detail than that, there are links that get you into very technical peer-reviewed publications as well, if that's what you wish. So what does the EPA say? The EPA is the agency in the United States that regulates everything environmental, including greenhouse gases. The EPA is very clear. The EPA says that transportation, cars, trucks, trains, planes, ships, contribute 28%, almost 30% of all greenhouse gases in the United States. Power production and use, another 28%. Industry, another 22%, and the number one here is the cement industry. And then comes agriculture. This is not, even though they're using a cow, this is not animal agriculture, this is all of agriculture that contributes to 9% of total greenhouse gases in the United States. According to the EPA emission inventory for this country, this is the official number for the United States, all livestock, beef, dairy, swine, everything, poultry, feed, combined produces 3.9% of our greenhouse gases. Let's call it 4. 4% of our greenhouse gases in the United States stem from livestock. 80%, 80, from fossil fuel sources. And that's this one, and this one. What Elizabeth Warren and AOC and others said the other day, that there are 3 different sources producing, they said 70%. What they were referring to is this. They were referring to the EPA emission inventory, saying that the 800-pound gorilla is the use of fossil fuel. Everything else is just smokescreen. They said it. They said it. Think about that. To me, that's just mind-boggling. I've never heard that before. There's just another depiction of the same thing. You see here the years 1990 to 2017, and the different colors here are the different sectors of society. This green area here is agriculture. It has not changed over the last 30 years. Okay, we are producing the same amount of greenhouse gases, but at the same time we are feeding this nation and feeding the world. And we've got to do that, okay? Feeding people is not wasting water. Feeding people is not wasting land. Feeding people is a strategic need of this country and the world. I mean, really, I get very passionate about it when people go onto accusing agriculture of depleting all natural resources, when in fact we have huge sectors that go underneath the radar screen because our special friends are winning over and over and over again. And people in agriculture lean back and say, oh, we don't believe in climate change. Leave us alone with that crap. You know what I'm saying? When you go to your clients, when you talk to your cattlemen, when you talk to your dairymen about this topic, most of them will say, I don't believe in any of that, right? Is that true? I can tell you one thing. That is the worst thing that can happen to our sector. And the reason for this is that it's a major societal issue that the vast majority of everybody in urban centers cares deeply about. Okay? And they are the customers buying that beef and buying that dairy. And if they say this is a big topic for us, and the people who produce that stuff say, well, we don't care about that, then it shows a lack of empathy. That's the last thing you want, because otherwise, those special friends who produce the alternatives, meat alternatives, dairy alternatives, they will jump right into that gap. Believe me, I know what I'm talking about. I have met the founders and presidents of Impossible Foods, of Beyond Meats, and so on. They are ready to jump onto the opportunity. Agriculture needs to understand they are contributing to greenhouse gases. They do have a contribution to warming, but that contribution is a very minor one. We have, over the years, done research to quantify. We know the beef sector in the United States is responsible for 2% approximately of all greenhouse gases. 2%. It's not nothing, it's something, but it's 2%. Dairy is approximately the same, a little bit less. So we know what it is, and both of these sectors and other agricultural sectors have made pledges for further reductions. That's more than anybody else in this country can say for themselves. It's time to stop that we don't believe in this discussion. Because if we don't believe in this discussion, we'll just go away. So there's the so-called 2050 challenge. And many of my students in animal science and throughout various campuses I talk at are very, very committed to this topic. What the 2050 challenge describes is what people generally say is, oh, we have a growing demand of human population and we'll have a challenge feeding that. That's a story that needs to be told in a very different way. And I tell you how I tell it. This slide here shows on the x-axis the year 1750 to 2050, hence the name the 2050 challenge. On the z-axis you see the total number of people in the world. I just turned 50. When I was a little boy, we were here at 3 billion people. Today we are at 7.6 billion people, and by the time I'm an old man, we'll be at 9.5 billion people. In other words, throughout my lifetime and yours, human population on this planet will have tripled. We'll have 3 times more people on this planet, but not 3 times more resources to feed these people. We'll not have 3 times more land, water, fertilizer, and so on to feed these people. And that brings us to a situation where we need to make ethical choices as to how we grow food. When I talk to people in Davis, California, a quite liberal place, about how we should grow food, when I go to the farmer's market and I ask them what they think food production should look like, a swine farm or a poultry farm, you know what they say? What do you think they say a swine farm should look like? How many pigs do you think? 50, max 100. They're preferentially, I mean, they would prefer that the farmer knows them by name, okay? A poultry farm with more than 200 chickens is a factory farm in their eyes, okay? That's just the people out there. That's who we're dealing with. That's the general population, okay? I have news for them. That dairy or that beef operation or that poultry operation of the 1950s is a thing of the past. It will not come back, and it's a good thing that it doesn't come back. And we in agriculture need to stop portraying it as the gold standard. Every time I walk my dogs in the morning, some creamery truck drives by, and what's depicted on that creamery truck? Happy California cows on pasture, in the background a red barn, okay, totally romanticized, and everything is humanized. That is a strategic mistake of doing that, because we are putting into people's heads that this is the way it should be. I tell you, dairy in 1950 was everything but sustainable. Those animals were in tie-stall barns. They were, hooked up to a pole. They could stand up and lie down. That was it. They were hand-milked by stoop labor. The milk went into a bucket and stood there until somebody eventually picked it up. Food safety was dismal. The environmental impact was tremendous because the manure went into the next creek to be transported off. And the financial viability of these farms was horrific. It is horrific today, but it was even worse then. You tell me what's the gold standard about that, and then tell me why we are still depicting that as such. Sometimes we are our own worst enemies in that regard. Coming back to my slide here, there are two different colors you see here. Human population increase. On the one hand, you see that in developed countries, human population is plateauing. In developing countries, it's exploding. This is one of my favorite slides. It shows the world and a circle over Southeast Asia, and that circle contains more people in it than the rest of the world combined. More people live inside the circle than outside the circle. Clearly one of the hotspots for human population increase. But not the only one. Southeast Asia will increase by 41%, Africa by 50, almost 50%, South and North America will increase slightly, Europe will shrink. Clearly the 2050 challenge is one around South and Southeast Asia and Africa. This slide here shows it nicely too. It's not China. China will decrease human population, but Bangladesh, India will increase by a quarter. And those countries, those African countries in red, will double their human population every decade. Every decade they're doubling human population. That is the 2050 challenge right there. Don't let people tell you that we are going through this population explosion and we will run out of food. This is not happening here. It's not happening in the Americas. It's not happening in Europe. It is happening in these countries. And they either get a grip on how to plan population appropriately through better education of particularly the girls in those countries who oftentimes don't go to school, are barred from going to school, or because of lack of contraception and so on. So this is the 2050 challenge right there. And on top of that, we have this real limitation of cropland. Whether we have 3, 7, 9, or 12 billion people in the world, this is the only land we have available to grow crops. And I want to show you a little depiction that I think is very powerful. So imagine this sheet of paper, a regular sheet of paper, being the surface of the entire Earth. I will now fold this paper, and I will fold it twice, until it's approximately postcard size. What you see now is all land in the world. So the entire sheet is the entire Earth, and this here is all land in the world. Now, this here is my business card. And the equivalent amount of land represented by my business card is all agricultural land. So this is all land in the world, and this is all agricultural land in the world. Everybody with me? Now I take my business card and I fold it to one piece that's 2/3 and the other piece that's 1/3 its original size. And then I rip my own business card into pieces. So again, this is all agricultural land. The 2/3 piece of my business card is all marginal land. This is the land, agricultural land, that's not suitable to grow crops because either the soil is not good enough, not fertile enough, or there's not enough water. 2/3 of all agricultural land, and that's a take-home message for you, 2/3 of all agricultural land in the world is marginal. We cannot use it to grow crops. But what do we do with that land? Grazing with what? With ruminants. Ladies and gentlemen, that is your theme. We use 2/3 of all agricultural land in the world with ruminant livestock. Why? Because the only thing that grows there is cellulose-rich material that only ruminant animals can digest, and they make this stuff into highly valuable human animal source foods. 2/3 of all agricultural land on marginal. The remainder here, that 1/3 of my business card, is all arable land. And here's where we grow crops for everything else. This is how resource limited we are. And this, ladies and gentlemen, is a depiction of how small our resources are to feed this growing number of people in the world. We have to get that into people's heads, that we cannot go back to the 1950s, where we were extremely inefficient, but that efficiencies have everything to do with food security in the years to come. There's no way around that. Turning challenges into solutions. If you think of the entire food supply chain from cradle to grave, what do you think has the most detrimental environmental impact of everything we do around food, from growing to consuming to everything? Food waste. Food waste. This photo from the National Geographic shows a US family surrounded by the food they waste over a period of 1 year. Ladies and gentlemen, 40%, 40, of all food we produce in this country goes to waste. This slide here shows, and I know the font is small, it shows the entire North American food losses chain from production, that's farms, to post-harvest, processing, distribution, and then consumer losses, that's us at home. And then it shows the different categories from grains to seafood, fruits and vegetables, meat and milk. Again, grain, seafood, fruits and vegetables, meat and milk. Grain, seafood, fruits and vegetables, meat and milk. We are wasting between 50 to 60% of all fruits and vegetables grown in this country. And 10 to 20% of all animal source foods. A much lower number than the fruits and vegetables, but still a number too high. I think everybody would agree. If our special friends were really serious about reducing the food-related environmental footprint, that is the 800-pound gorilla they would pounce on. But no, they rather talk about farting cows. I will now show you something for which I was scolded and celebrated. I don't know what you will say to this, but I think it's very insightful. I will show you a slide that has 3 items on it. 3 items. 2 of those 3 items are meat alternatives. One is the Impossible Burger, one is Beyond Meat. And the 3rd item is dog food, dog kibbles. And you look at those ingredients, and then I ask you, what do you think is the food, is the dog food? So 3 items, left, center, and right. Look at those ingredients. Give you a few seconds. And make up your mind, which of the 3 is the dog food? How many of you say the dog food is to the left? Show me your hands. Don't be shy, okay? It's just us. How many of you say dog food is in the center? How many of you say dog food is to the right? All right. Would everybody in the room agree that they are very similar? And I mean, you are experts, right? I mean, you are veterinarians. You are trained in this stuff. But even you are kind of thrown off a little bit, right? So here's the solution here. They are posing themselves as the solution to what they call the world's worst environmental footprint. And that is livestock. They say, eat our stuff in order to reduce our environmental harm. That's what they say. Patrick Brown from Impossible Foods, he says publicly by 2035 he wants to get rid of all animal agriculture and replace all that animal protein with his Silicon Valley stuff. I've heard it from him personally. Believe it or not, once I had dinner with him when I served in the National Academies, and he was a guest speaker there and I was a committee member. And we sat there over dinner, and he said during dinner that he once, when he was a graduate student, ate dog kibbles. And I said, are you kidding me? Why? And he said, because they're nutritious and I had no money, so that was that. So that's what led me to then later look into the ingredients of that stuff. His stuff. Because I thought back to our little dinner conversation. This is a bunch of ultra-processed food. I don't even want to call it food, but it is ultra-processed, and that's their soft underbelly. Because, yes, they have a low environmental footprint compared to livestock, there's no doubt. But who wants to eat it once they know how it's being made? I certainly don't. So, a couple of slides. Oh, my time is running. A couple of slides here that I think are important. This one here shows dairy production per cow per year on the x-axis and carbon footprint on the y-axis. It shows that there are many countries with dairies that have very low productivity, very dismal amount of milk produced per cow per year. And then there are others with high productivity. The US is not depicted on this slide because we would be way off here. We would be over here. We are producing about 23,000 pounds of milk per cow per year. 23,000 pounds of milk per cow per year. We are producing at least 10 times more, in some cases 20 times more, than many of the developing countries in the world that really need animal source foods because they are nutrient deficient. We are the world leader in dairy, in beef, in all of the livestock commodities. On this slide, you see different regions in the world and the carbon footprint per unit of food and protein-corrected milk. And again, North America has not the highest, it has the lowest carbon footprint of any region around the world. That's true for dairy, but it's also true for beef and all the others. How did we get there? How did we get to a stage where we have minimized environmental footprint of our livestock? 4 things. We have improved reproduction. We have improved your sector, veterinary care, vaccination, treatment of animals. We have improved genetics, and we have learned to feed more energy-dense diets. The combination of those 4 has allowed us to shrink herds to historic levels. Never have we had fewer livestock than we do today. On the beef side, we used to have 140 million beef cattle. Today we have 90. But we are producing the same amount of beef with this much smaller herd. On the dairy side, we used to have 25 million dairy cows. Today we have 9. But even though we have much fewer dairy cows today, we are producing 60% more milk with that smaller herd. The carbon footprint of a glass of milk has shrunk by 2/3. Just told you we have 9 million dairy cows. How many horses do we have in this country? 9.5. We have more horses in the United States than dairy cows. Have you ever heard anybody talk about methane from horses? And you never will. How about 170 million dogs and cats? They are consuming the same amount of nutrients as 70 million people, 7-0. Also, of course, nobody talks about that. Not that I have a beef with horses, dogs, or cats. I'm just saying, of course, they also have environmental footprints, but our special friends will only focus on what? Cows. Pork production has tripled over the last 50 years. One more example here from China. I spent a lot of time in China. I have an appointment at a Chinese university. And I'm always blown away. Before African swine fever hit China, they already had a big issue. They are producing half of the world's pigs in China. 1 billion per year. But what I find more staggering is that they have a pre-weaning mortality of 40%. 400 million pigs never make it to market in China. 400 million, that's a larger crop than our entire US crop that goes to the landfills in China. And that's China. There are many other places in the world that are much less efficient than China. So I think we have done a pretty good job here in the States, but we have done a really bad job in talking about the good job we have done. We have to do much better in communicating with the public, which is increasingly often interested in where their food comes from, as to how that food is being produced and why and how we care for those animals, how we care for their welfare, for their housing, for their husbandry, how we care for the environmental footprint of those animals. It's no longer okay for us to say, leave us alone, we know what we're doing. When they ask, we need to talk. When a 20-year-old, a millennial, comes to me and says, I want to know something about antibiotics in milk, or pus in milk, or who knows what they ask me, then I need to take them seriously and talk. Because if I don't, they keep asking, and sooner or later they will talk to Peter, to HSUS and others, and they're always very happy to talk to them. You know what I'm talking about, right? So, I will close. I will thank you very much for your attention. I'm happy to entertain any questions if we have a minute or two. Thank you very much.
Thank Dr. Mitloehner. I see a question over here. We'll try to use the mic if we can so people can hear.
Yes, I very much enjoyed your talk, and I wanted your thoughts about, I don't know if you're familiar with Gregory Wrightstone's book on Inconvenient Facts, where he talks about environmental global warming is really an 11,000-year cycle, and that we're at the low end of the carbon dioxide part of the cycle, and we actually would be more productive if we allowed carbon dioxide levels to raise.
Yeah, I know. The denialists, they bring this up. I can tell you, I don't buy into this at all. I know there have always been phases of heating and cooling, of CO2 going up and down, but the normal ranges that we have had over the last thousands of years, they've had an upper and a lower boundary, and we have far exceeded the upper boundary, and that happened throughout the last 50 years. And if you look at all the data, all the gases and so on that were emitted during that time, there's a very strong case for correlation between CO2 emissions in particular and fossil fuel-related activities. So I will tell you that I firmly believe that climate change is happening, that we do have a grip on what's contributing to it, that livestock has a share, but that share is very slow, and a small, and that we have a really good grip now on how we can further reduce it. So I think that's the way I would like to see that discussion going on. Yes?
Quick question. Do we have an effective way of quantifying how much carbon, say, a native warm season grass does versus a different crop? And is there opportunity for both economic or other in some of that area?
To sequester carbon?
Yes.
Yes, we do have a good grip of or on how different forages and other feedstuff take on, let's say, CO2 out of the atmosphere. One of the most effective ones is a C4 grass called corn. That stuff gobbles enormous amounts of CO2 out of the atmosphere. But of course, once the animals eat it, that CO2 will be respired. But while it grows, it does a really good job in taking it out. So yes, we do have a good grip on this. And I'm actually happy to inform you that the EPA inventory and also the IPCC global inventory says that agriculture and forestry combined take out way more greenhouse gases out of the atmosphere than they put in. Think about what I just said. And that's because of soils and plants assimilating and sequestering enormous amounts of carbon. But there's no credit for that whatsoever. But you find it in every report. The media has never talked about that.
We have time for one more question.
I told Dr. Mitloehner before he started that he was my hero. I saw him on some little 5-minute segments on chasing down Madison Brown on RFD TV. And I would like to challenge all of us to take something simple like this paper that he folded. It's very graphic, it's easy to understand, and it's not hard to carry, and share that with as many people that we have in contact with that we can. I think we can do a world of good if we just do something simple like that. I'd like to ask Dr. Mitloehner, are there any technological ways that we can reverse the accumulation of the greenhouse gases that are already in the atmosphere and continue to be? Or is it just a matter of mitigating the increase? Can we stop it, or is there any way to do that?
Yeah, so first of all, thank you very much for your comments. Secondly, what's really great is that there's actually a big leverage on the methane front. Whenever we reduce methane, for example, by becoming more efficient, when we have shrunk our livestock herd, the dairy herd, from 25 to 9 million, we have taken a lot of methane out of the atmosphere. When you reduce methane, you induce something called global cooling. Think about that for a second. Why? Because you take methane molecules out, and therefore you pretty much poke holes into that blanket I described before. And now radiation can go back into space. If we reduce methane, we induce global cooling, and we are counteracting the heating aspect of fossil fuel use. So on the methane side, we can use feed additives. We have done research on feed additives. I think in the next 5 years, we'll have effective means of reducing enteric emissions by 30–40%. And the same is true on the manure side. And I could talk forever on the CO2 side, but I don't have time.